Welcome to our introduction on unleashing the power of Squid, a powerful open-source proxy server and web cache daemon. Squid plays a crucial role in enhancing internet traffic management by providing a wide array of features to optimize network performance, security, and control. At its core, Squid acts as an intermediary between clients and servers, caching frequently accessed web content to reduce server load and improve response times. This means that when a client requests a web page, Squid checks its cache first. If the page is found, it is served directly from the cache, bypassing the need to retrieve it from the original server. But Squid's capabilities extend far beyond basic caching. It offers robust access control mechanisms, allowing administrators to define granular rules for user access to specific websites or content categories. This is essential for organizations looking to enforce acceptable use policies, restrict access to inappropriate material, or prioritize critical traffic. Additionally, Squid provides comprehensive bandwidth management tools. This enables administrators to allocate bandwidth effectively, ensuring that essential services receive adequate resources while preventing bandwidth hogs from monopolizing the network. The versatility and power of Squid make it an indispensable tool for a wide range of users and organizations. Internet service providers leverage Squid to enhance their network infrastructure, optimize bandwidth utilization, and provide value-added services to customers. Businesses rely on Squid to improve employee productivity by accelerating web access, enforce security policies, and control internet usage. Educational institutions utilize Squid to filter inappropriate content, manage internet access for students, and create a safer online environment. Whether you're a network administrator, system architect, or simply looking to optimize your home network, Squid offers a comprehensive solution for mastering internet traffic. Let's dive into the installation and configuration of Squid, which is a straightforward process on most Linux distributions. The exact commands may vary slightly depending on your distribution, but the general steps are similar. Typically, you would use your distribution's package manager to install Squid. For example, on Debian-based systems like Ubuntu, you would use the command sudo apt-get install squid. This will download and install Squid along with its necessary dependencies. Once installed, Squid comes with a default configuration file, usually located at etc/squid.conf. This file contains numerous options and directives that control Squid's behavior. Configuring Squid involves modifying the squid.conf file to tailor it to your specific needs. For beginners, it's recommended to start with the basic settings and gradually explore more advanced features. Key configuration options include defining the port Squid listens on, specifying the cache size, and setting up access control lists. For example, to change the default port from 3128 to 8080, you would modify the http_port directive in the squid.conf file. It's crucial to carefully review and understand each configuration option before making any changes. After making any configuration changes, you need to restart the Squid service for the changes to take effect. This can usually be done with the command sudo service squid restart. It's important to test your configuration thoroughly after any modifications to ensure that Squid is functioning as expected. You can use a web browser to access websites through the Squid proxy and observe the results. If you encounter any issues, carefully review your configuration for errors and consult the Squid documentation for troubleshooting guidance. Caching is one of Squid's core functionalities, playing a pivotal role in accelerating web access and reducing bandwidth consumption. When a client requests a web page, Squid checks its cache first before fetching it from the origin server. If the page is found in the cache, it's served directly to the client, resulting in significantly faster loading times. This is particularly beneficial for frequently accessed websites and static content like images, style sheets, and JavaScript files. By caching these resources, Squid reduces the load on origin servers and frees up bandwidth for other traffic. Squid's caching mechanism is highly configurable, allowing administrators to fine-tune its behavior for optimal performance. You can define the size of the cache, set expiration policies for cached content, and even specify which types of content should be cached. For example, you can configure Squid to aggressively cache images and videos while bypassing caching for dynamic content that changes frequently. Additionally, Squid supports various caching hierarchies. This allows you to create a network of Squid servers where higher-level caches can fetch content from lower-level caches, further improving efficiency and reducing latency. To maximize the benefits of caching, it's essential to understand the different types of caching Squid offers. There's regular caching, which stores content in memory and on disk, and there's also RAM caching, which stores content exclusively in memory for ultra-fast access. Choosing the right caching strategy depends on your specific needs and available resources. For example, if you have ample RAM caching can significantly boost performance for frequently accessed content. However, if storage space is a constraint, regular caching with appropriate expiration policies might be more suitable. By understanding and effectively configuring Squid's caching mechanism, you can transform your network's performance, making web browsing a much smoother and faster experience. Access control is a crucial aspect of Internet traffic management, enabling organizations to regulate user access to online resources, enhance security, and enforce acceptable use policies. Squid provides robust access control mechanisms, allowing administrators to define granular rules for user access to specific websites or content categories. These rules can be based on various criteria, including IP addresses, user authentication, time of day, and URLs. For example, you can restrict access to social media websites during work hours, block access to known malicious websites, or prioritize access to critical business applications. Implementing access control in Squid involves creating access control lists, ACLs, and associating them with specific actions. ACLs define a set of criteria that identify users or requests. Actions define what happens when a request matches an ACL. For example, you can create an ACL that matches all IP addresses within a specific subnet and then associate that ACL with an action that allows access to a particular website. Conversely, you can create an ACL that matches specific URLs and associate it with an action that denies access. Squid's access control system is highly flexible, allowing you to create complex rules and hierarchies to meet your specific requirements. You can combine multiple ACLs and actions to create intricate control scenarios. For example, you can allow access to a website only during specific hours, from specific IP addresses, and only after successful user authentication. This level of granularity gives administrators unparalleled control over network access, ensuring that resources are used appropriately and that sensitive information is protected from unauthorized access. By leveraging Squid's access control features, organizations can create a secure and controlled online environment that aligns with their policies and objectives. Bandwidth management is another key aspect of effective Internet traffic management, enabling organizations to optimize network utilization, prioritize critical traffic, and prevent bandwidth hogs from monopolizing network resources. Squid offers a range of bandwidth management tools that allow administrators to control how bandwidth is allocated and consumed. These tools include delay pools, bandwidth limits, and priority queues. Delay pools allow you to define different classes of traffic and assign specific bandwidth allocations to each class. This ensures that high-priority traffic, such as business applications or VoIP calls, receives adequate bandwidth, while less critical traffic, like streaming media, is allocated a lower priority. Bandwidth limits allow you to set hard limits on the amount of bandwidth a specific user, IP address, or website can consume. This is particularly useful for preventing bandwidth-intensive activities from saturating the network and impacting other users. For example, you can set a limit on the amount of bandwidth allocated to file downloads, ensuring that downloads don't monopolize the connection and prevent other users from accessing the internet. Priority queues allow you to prioritize certain types of traffic over others, ensuring that critical data packets are transmitted first, even during periods of high network congestion. Implementing bandwidth management in Squid involves configuring the appropriate directives in the squid.conf file. You can define delay pools, set bandwidth limits, and configure priority queues based on your specific requirements. It's crucial to carefully plan your bandwidth management strategy, taking into account the needs of different user groups, the types of applications used, and the overall network capacity. Monitoring network usage patterns and adjusting bandwidth allocation accordingly is essential for ensuring optimal network performance and user satisfaction. By effectively utilizing Squid's bandwidth management features, organizations can ensure that their network resources are used efficiently, critical traffic is prioritized, and bandwidth hogs are kept in check. Logging and monitoring are essential aspects of managing any network service, and Squid is no exception. Squid provides comprehensive logging capabilities, allowing administrators to track various aspects of its operation, including user activity, cache performance, bandwidth usage, and security events. This information is invaluable for troubleshooting issues, identifying performance bottlenecks, detecting security threats, and optimizing Squid's configuration. By default, Squid logs events to a file typically located at var-log squid-access.log. This file contains detailed information about each request processed by Squid, including the client IP address, requested URL, HTTP status code, and response time. Analyzing Squid's logs can provide valuable insights into network usage patterns, identify popular websites, and detect potential security breaches. For example, a sudden surge in requests for a specific URL could indicate a distributed denial of service (DDoS) attack. Similarly, a high number of failed requests could point to connectivity issues or misconfigured access controls. To facilitate log analysis, various tools and techniques are available. You can use command line utilities like grep, awk, and sort to filter and analyze log data, or you can employ specialized log analysis software that provides graphical dashboards and reporting features. In addition to log analysis, real-time monitoring of Squid's performance is crucial for ensuring optimal operation. Various monitoring tools can be used to track key metrics such as cache hit rate, bandwidth utilization, and request latency. These tools can provide real-time alerts when performance thresholds are exceeded, allowing administrators to proactively address issues before they impact users. Monitoring can also help identify trends and patterns in network traffic, enabling administrators to optimize Squid's configuration for maximum efficiency. By effectively leveraging logging and monitoring tools, administrators can gain valuable insights into Squid's performance, proactively address issues, and ensure that the proxy server is operating at peak efficiency. Security is paramount in today's interconnected world, and Squid plays a crucial role in safeguarding networks from various threats. While Squid itself is generally secure, implementing security enhancements can further strengthen its defenses and protect your network from malicious activities. One essential security measure is to keep Squid up to date with the latest security patches. Regularly updating Squid ensures that any known vulnerabilities are addressed, minimizing the risk of exploitation. Additionally, it's crucial to review and configure Squid's security settings appropriately. This includes disabling unnecessary features, restricting access to sensitive configuration files, and enabling logging for security-related events. Implementing strong access controls is another vital aspect of securing Squid. By defining granular rules for user access, you can prevent unauthorized access to sensitive resources, block malicious websites, and enforce acceptable use policies. Consider using authentication mechanisms to verify user identities and restrict access based on user roles and permissions. Furthermore, Squid can be integrated with external security tools, such as intrusion detection systems, IDS, and antivirus software, to enhance threat detection and prevention capabilities. By forwarding Squid's logs to an IDS, you can monitor for suspicious activities and receive alerts when potential threats are detected. Another important security consideration is protecting Squid from denial of service, DOS, attacks. DOS attacks aim to overwhelm a server with traffic, making it unavailable to legitimate users. Squid offers various mechanisms to mitigate DOS attacks, such as rate limiting, connection limiting, and blacklisting. Rate limiting restricts the number of requests a client can make within a specific time frame, preventing a single client from flooding the server with requests. Connection limiting restricts the number of concurrent connections a client can establish, preventing a large number of connections from overwhelming the server. Blacklisting allows you to block requests from known malicious IP addresses, preventing them from reaching Squid altogether. By implementing these security enhancements, you can significantly strengthen Squid's defenses and protect your network from a wide range of threats. Beyond its core functionalities of caching, access control, and bandwidth management, Squid offers a plethora of advanced features that extend its capabilities and allow for highly customized configurations. These features cater to a wide range of needs, from optimizing content delivery to enhancing security and integrating with external systems. One such feature is transparent proxying, which allows Squid to intercept and process network traffic without requiring clients to be explicitly configured to use the proxy. This is particularly useful in environments where you want to enforce policies or caching without requiring end-user configuration changes. Another powerful feature is URL rewriting, which enables you to modify URLs on the fly, redirecting requests, manipulating content, and customizing the user experience. Squid also supports various authentication mechanisms, allowing you to verify user identities and restrict access based on user roles and permissions. Common authentication methods include basic authentication, NTLM authentication, and LDAP authentication. Integrating Squid with external authentication systems enhances security by centralizing user management and enforcing consistent access policies across the network. Additionally, Squid can act as a reverse proxy, sitting in front of one or more web servers and forwarding requests to the appropriate server based on the requested URL or other criteria. This is commonly used for load balancing, distributing traffic across multiple servers to improve performance and availability. Squid's advanced features extend its versatility and make it a powerful tool for addressing a wide array of network challenges. Whether you need to optimize content delivery, enhance security, customize user experience, or integrate with external systems, Squid provides the flexibility and control to meet your specific requirements. By exploring and leveraging these advanced features, you can unlock the full potential of Squid and transform it into a highly customized and powerful solution for your network infrastructure. Squid's versatility and robust feature set make it an indispensable tool for a wide range of practical applications across various industries and sectors. Its ability to cache content, control access, manage bandwidth, and enhance security makes it a valuable asset for organizations of all sizes. Internet service providers, ISPs, heavily rely on Squid to optimize their network infrastructure and provide value-added services to customers. By caching frequently accessed content, ISPs can significantly reduce bandwidth consumption, improve network performance, and lower operating costs. Squid also enables ISPs to implement bandwidth management policies, ensuring fair usage and prioritizing critical traffic. Businesses across various sectors leverage Squid to enhance employee productivity, enforce security policies, and control internet usage. By caching web content, Squid accelerates web access, reducing loading times and improving employee efficiency. Squid's access control mechanisms allow businesses to restrict access to inappropriate or unproductive websites, ensuring that employees focus on work-related tasks. Additionally, Squid's bandwidth management tools help businesses optimize network utilization, prioritize critical business applications, and prevent bandwidth-intensive activities from impacting overall network performance. Educational institutions utilize Squid to create a safer and more controlled online environment for students. Squid's content filtering capabilities allow schools to block access to inappropriate material, ensuring that students are not exposed to harmful or distracting content. Additionally, Squid enables schools to manage internet access for students, restricting access during class hours, or limiting bandwidth usage for non-educational activities. By implementing Squid, educational institutions can create a more secure and focused online learning environment that promotes academic success. In conclusion, Squid's practical applications span a wide range of industries, from optimizing network infrastructure for ISPs to enhancing security and productivity for businesses, and creating a safer online environment for educational institutions. Its versatility and robust feature set make it an essential tool for any organization looking to master internet traffic and optimize their network infrastructure. In conclusion, Squid stands as a cornerstone of effective internet traffic management, offering a comprehensive suite of features that empower organizations to optimize network performance, enhance security, and exert granular control over internet access. Its robust caching mechanisms accelerate web access, reduce server load, and minimize bandwidth consumption. Squid's sophisticated access control system enables organizations to enforce acceptable use policies, restrict access to inappropriate content, and prioritize critical traffic. Additionally, Squid's bandwidth management tools ensure efficient utilization of network resources, prioritize essential services, and prevent bandwidth hogs from monopolizing the network. Squid's versatility extends beyond its core functionalities, encompassing advanced features such as transparent proxying, URL rewriting, authentication mechanisms, and reverse proxying capabilities. These features cater to a wide array of needs, from optimizing content delivery to enhancing security and integrating with external systems. Squid's practical applications span various industries, from optimizing network infrastructure for ISPs to enhancing security and productivity for businesses, and creating a safer online environment for educational institutions. Whether you're a seasoned network administrator, a system architect, or simply seeking to optimize your home network, Squid provides an indispensable toolset for mastering internet traffic. Its open-source nature, extensive documentation, and active community support make it an accessible and powerful solution for organizations of all sizes. By leveraging Squid's capabilities, you can transform your network infrastructure, enhance security, and create a more efficient, controlled, and secure online environment.